So for this open box, the side length for each of the squares we're cutting out in the corners is x, and we want a polynomial function to represent the volume of the box in terms of x. So what I'm going to do is think about, there we go, the distance in between here. So once I fold up the sides, the height of my box will be x. And then the other two dimensions, the length and the width, well, here I had 30. I'm cutting off x on both sides, so 30 minus 2x for one dimension. And 25 was the full length, but I cut off 2 x's, so 25 minus 2x, that's the other dimension. I wouldn't need to sketch a three-dimensional version of it, but I did, just because it kind of helps me in my head sometimes. So here I have the dimensions of this box. So I have a length, a width, and a height. And if I can see those, I can write my equation. So even without that, we could have written this equation where I have the volume of the box as a function of that x dimension. And once you have this down, we're going to graph it again. So you can put it on your calculator. We'll have a look at it there, and then we'll think about what the domain is for this situation. Remember that we said for a polynomial function, domain is all real numbers. But in the context of this question, having an x value that's any real number doesn't make sense. You can't have a negative length that you're going to cut off. And there's some other limitations that we'll talk about too. So here's what my graph looks like. If you can sketch something similar to this in your notes, that's great. And we could figure out these x-intercepts as well. We could do it from the equation or from the graph. I'm going to do it from the equation. So I'm going to say, well, when is volume 0? When x is 0, so that's this point over there. Here, when x is 12.5, because 2 times 12.5 is 25, 25 minus 25 is 0. So this point here is at 12.5. And then the next point, next x-intercept, will be at 15. Not 150, 15. I would like you to talk to your neighbor and convince your neighbor this is what the domain for this situation should be. So tell them what you think it is and convince them you're right. All right. So I should talk about how I would get my window setting. So I did that on Desmos, but let me just quickly enter this. I maybe didn't need to bong that right away. Oh, while I'm entering this, if you have an Inspire, when you're going to enter something in factored form, the Inspire requires you to put multiplication signs between the X and the bracket. On the TI 4 Plus, you don't have to. You can just do the X and then a bracket. But the Inspire, you need a multiplication in between there. Okay, so this. Okay, so there you can see the function as I've entered it, and I will just do a zoom standard because that's typically what we'd see. So, zoom standard. What do I see? Nothing. Why do I see nothing? Let me try a trace. So I have 0, 0 showing up, so I do have a graph. And if I scroll to the right, I'm at 0.2 and 155 already. So my graph is shooting up really fast. I can't see anything because my graph is so steep here. So I know I need to see more vertically. So what I would probably try as a start is I'd come to the zoom option and I would scroll down to 0, I think it is. Yeah, and I would try a zoom fit, which sometimes works, sometimes doesn't work. It's a starting point. Well, a second starting point. So I'll hit enter and I get a zoom fit. And okay, so I see my graph coming up. Oh, and I can see a maximum there, but then there's something happening further to the right. I'm not interested in negative x values or negative y values, because negative y would be a negative volume, meaningless. Negative x would mean the piece I'm cutting off is uncut. I don't know what that even means. It means nothing. So then I'll look at my window and I'll say, well, I'm doing better. I think I want to see further to the right. So I'm going to change my x max. And I can see kind of that curve, so it's not too bad. So I'm going to only go up to, let's say, 20. My y min, that's way below what I need, and my y max is about 1500. So let's change this to negative 1000. And this one, let's go a little bit more than 1500 so I can see above that curve. So let's go 3000. And I should probably change my x scale, y scale. I won't this time. What that's doing is it's telling how often you're going to get a tick mark. So maybe I will change my y scale. Since I'm going by thousands, let's say I'll put a tick mark at every 500. No, every 100. Now I'll graph. So vertically the tick marks are at 100. So there, now I can see a little bit more of the graph. So I started with the zoom fit. For some people with Inspires, it didn't help much because it kind of looked cubic. We were hoping for a maximum, so we knew we needed to change the y max a little bit. So it's sort of some guessing and checking there. But I also traced, so that's helpful too, or look at the table, because that can give you a hint of what your y values are reaching. Okay, that will be there. And I'll just close this. My domain. It's really just this piece of the graph here that's going to be useful. Because if I have an x value, let's say that's 20, I get a positive volume, but if I think in this context, if I do 25 minus 2 times 20, 25 minus 40 is negative. So basically I've cut off more paper than I have. So that's going to be useless up there. And in fact, if I pick something in between here, like let's say 14, well, I know I don't want that because it's negative, but let's just pretend I did. Here, if I do 25 minus 2 times 14, that's 25 minus 28. Again, it's negative, it's useless, I've cut off more paper than I have. So, my domain can only be between 0 and 12.5. Should it equal those or should it not equal those? I'll be flexible with that. Like a zero volume makes sense, but it's not helpful. So I'm just going to say my minimum will be 0, and we'll go with less than x, which is less than 12.5, but x can be any real number in that interval. We say any real number, but I can't measure every real number, but we'll just go with any real number anyhow. Go ahead.
So why are you putting in when you're not using the other subject now?
The left side or the right side? I'm not using the right side because once I get past 12.5, I'm cutting off more paper than I have. So if we look at this, and let's say it's this piece of paper here. There we go. This is 25. If I cut off 12 and a half, that's half the page. And I cut off half the page there, basically I don't have a square anymore. I cut off a whole section here and I can't really fold it up. So if I get any bigger than 12 and a half, there's not enough paper to cut off. So it has to be smaller than 12 and a half, so I'm going to have a dimension here for the sun. Good question. Third.
Why did we not look at anything past?
We didn't look at anything past 12.5 for the reason I just said, which was if I cut off 12 and a half, then I'm cutting off half of this piece of paper, and this dimension goes to 0. So I don't have any width. So this has to be less than 12 and a half, so I'm going to have some width in here. Other questions? Nope. We have 2.5 minutes. So then, the graph function, we say the domain, good number 2. Questions? I won't ask you to sketch a graph like this on a test or quiz, you'll just use it to answer a question. So typically this would be multiple choice, numerical response kind of question, because you can do it all by graphing. Multiple choice could be, I could give you an option for equations, or it could be answers to the question, or it could be domain. Those types of things could show up. Centimeter, centimeter, what's the maximum volume? You know how to do this. So second trace on TI-84 plus, and then calculate maximum, left bound, right bound, guess in between. On the Inspire, you just calculate maximum and drag across. Either way, you should end up with something other than a black line. How about 1,512 cubic centimeters about? And we're asked for the nearest cubic centimeter, so that's what we're doing. Good, so this is the y coordinate of the mass. And then for the next one, what size of square? That's going to be the x coordinate for the maximum. And we got it the same way. Oh, a marker here. That's the problem. Should be about 4.5 centimeters. So that was saying that this point, 4.5, comma, 15. So that's the x coordinate. Good. That previous question with the luggage one, we didn't actually finish the question because we didn't figure out all the dimensions. But here we're asked for all the dimensions too, so we're just going to take that x and plug it in. What's 30 minus 2 times 4.5? What's 25 times 2 times 4.5? Yeah, there you go. Those are the answers. That's enough for you to be able to do the questions. There's one more example here that we'll talk about Thursday maybe, because tomorrow you'll want all your time for the assignment. Here we go. You did it.